Okay, good morning guys. Welcome to another of the MoTec's webinar series. My name is Jamie Augustine and today's subject is how to view, update and insert GPS beacons with MoTec products. I'm just going to run through the slides and talk to you about them as we go. I also have a file available for you to download in the bottom left corner of your screen. If you look down at that point, you can download this file at any time you like. The file has within it a whole lot of coordinates for different tracks from all around the world that you'll be able to use at a later stage. You don't need to do it now, just at any time is fine. We're not actually going to refer to it, it's more a reference from this course for you. We will leave it up after the meeting has actually finished, so you don't need to do it during the meeting so you don't miss anything. The topics we're going to go through today are an introduction to GPS lap timing, generally what it is, how it works. We're going to talk about how you should mount the GPS on your vehicle. We're going to have a look at setting up the GPS beacons in SDL3. Although we'll only talk about it in SDL3 terms, the methods will be the same in ADL3, ACL and the like. We're going to show you how to find your start and finish lines using data in case you don't have a start-finish line listed for you. I'm going to talk to you about how you can auto-insert beacons on the off chance that you didn't get the beacon in time for your session. And we're going to talk about GPS troubleshooting. Okay, so we'll just go through some early information as we have each time. You probably all have done these before, so you'll know the information about the company, which is we've been around for a while. We're Australian owned and we are motorsport focused, and this is yet another one of our products that's primarily aimed at motorsport use. These are the guys that you will get to speak to or email to or hear from on the forum if you're after more information at a later stage. And again, it's good for you that you don't actually have me in there today. Alright, so let's have a chat about GPS units. Most people will understand and know about GPS from their phone, from their car GPS units. Motorsport-based GPS units are a little bit different in that they intend to give you a much higher update rate and a much higher accuracy than the normal road car style GPSs. A road car style GPS will update it around about 1 time a second. They do that because it's cheaper to do it and cost is all that they're worried about with that type of system. We need higher update rates. What we actually sell from MoTec is a 5 Hz GPS, but we can effectively take any sort of GPS that you might be able to get. We've previously supplied 10 and 20 Hz GPSs, all with a very high accuracy, perfect for motorsport usage. So what we actually gain out of a GPS is not only your position information like your road car GPS, we can also provide to you speed, altitude, heading, date, time and some GPS statistics. This is quite useful, especially the speed. Trying to install speed sensors on a car that has previously never had them is always a challenge and can be quite expensive from a mechanical implementation point of view. At least with a GPS, you can just place it straight onto the car. You don't need to put in wheel speed sensors and you will get speed very easily. Another good reason for this is if you have something like a boat where there are no wheels to actually measure speed off and paddle wheels don't work particularly well, GPS is an excellent way to work out where you are on the river or the lake and how fast you're going. The positional information from a GPS can be used within MoTec's i2 data analysis software to show your driven lines and to compare them and also create your track maps. So you can get quite a lot out of a GPS unit. So what is GPS lap timing, which is what we're talking about mainly today? Well, all you guys being involved in motorsport would understand you want to get your lap times instantly from when you are racing around a circuit. Previously, before GPS lap timing, you would have had to have had a transmitter on the side of the track and a receiver within the car. This would give you accurate lap time information instantly as you finish your lap. This method of using a transmitter and receiver requires you to remember to put your transmitter out, which is commonly forgotten. You have to have a battery there to provide power to the transmitter, which you need to remember to charge. You also need to remember at the end of your race weekend, when you're finished and you're packing up, to go back down pit lane and pick up your transmitter. So many free transmitters are available at racetracks at the end of a race meeting. You just need to go down and find them all down there. So with the GPS, you need to do none of that. All you need to do is put the GPS in an appropriate position on your car, and it will be able to work out where your latitude and longitude is and start lap timing when you cross a given location. So this is a really cost-effective alternative to traditional lap timing. The position of the start-finish line can be marked either by using a push button that the driver operates when he first passes the line, or you can enter the coordinates directly into the data acquisition system. What I'm going to talk to you about today mainly is the second method, which is the most common method. You type into the data acquisition system what the latitude and longitude is for the start-finish line, and every time you cross that position, it will actually give you your lap time. Okay, so the thing we're going to talk about next is mounting the GPS on your vehicle. If you can imagine what you do with a normal everyday road car is you just place your GPS on the dash. Now when you look around the sky with your GPS on the dash, it will tell you there's X number, 8, 9, 10, 11 satellites available for you to select from. And when it's only trying to update at 1 Hertz, it can always find a couple of satellites to give you a lock on where your position is on the road. But a race car is a different story. A race car, if you are quickly changing direction, will have to quickly hand itself off from one set of satellites to another when the roof of the car, if you're in a closed car, starts to interrupt the signal from the satellites that you were previously using. This isn't such a problem with a slow rate GPS such as a road car based GPS. But on a race car, you need to keep as many satellites and as consistent which satellites you use as possible at all times. So we recommend that you always mount your GPS external to the car and on the roof of the car. So don't place your high resolution, high speed GPS on the dashboard or the back parcel shelf of your race car and expect to get good GPS resolution. You need to place it generally on the outside of the vehicle, and we do prefer that you place it on a metal disc that is larger than the size of the GPS. The metal disc helps stop reflected GPS data being received through the bottom of the GPS unit. The metal disc means that only GPS signals that are directly from above the unit will actually be received. So in these instances, where Peter's just placed that circle to completely cover what I'm trying to show to you, you'll see that they've placed the GPS on top of a metal surface. You'll have to take my word for that right now. And in the car on the left, which is actually a Le Mans prototype car, they've got a metal area on the top of the dashboard which has clear view of the sky in every direction. They're the types of things you would do to install a GPS in a car. So once you've got the GPS installed in your car and you've got it wired up according to the wiring diagram that you would have received with your GPS, you need to go and tell the SDL3 that I've now got a GPS and that I wish to use the GPS to do my lap timing. So what you need to do is open up SDL3 Manager and you'll get the screen that you can see in front of you, as most of you guys would already know. The place to set up the GPS to tell the dash that I have a GPS is in the Connections Communications screen. So if you were to click on that, you'll see this screen here. So this screen that you're looking at says what type of communications am I receiving the GPS on and what sort of GPS is it. The only GPSs we really support for lap timing at the moment are GPSs that use NMEA standard message formats, which is the general standard of messages from GPSs. It's National Marine something or other, don't worry about that, but it's a standard of GPS transmission that most GPSs will use. So if you select the RS232 tab at the top of the communication setup and choose select, the box on the bottom right will be the list that you'll see in front of you. If you look down through that list, you'll find GPS standard, RMC and GGA. All you need to do is select that option, then click OK from the communication template screen. That will drop you back to the communication setup screen, and your screen will look very much as the one is in the picture in front of you. The only other thing you have left to do is tell it the baud rate. Now this can be a little trickier. If the GPS is supplied by MoTec, have a look through the manual and you'll find what the appropriate baud rate is that the GPS is going to work on. The standard baud rate for our GPS-G1 5Hz Garmin GPS is 19200, and you'll find that in the manual. If you're using a non-MoTec supplied GPS, the information should be in the manual. Keep in mind this baud rate is often adjustable by using proprietary software of your GPS, so you may not have the number that is specified. It's about the main thing that you can do wrong, but if you know for sure that it was sent to you with 192, then set it up as 192. Once you have set up the baud rate, you need to do nothing else other than click OK, and the dash will now start reading the RS232 input stream at 19200, looking for your GPS information. So now we can assume your GPS is correctly configured within the dash. We want to now tell the dash, I want you to use a GPS to determine where my beacon is going to be. So you click on Calculations, then Lap Time and Number. When you click on Lap Time and Number, you'll see this screen pop up, the Lap Time and Number setup screen. Under the beacon type, you'd need to drop down, and in the list you'll find GPS. One of the things I would recommend to you that's not on this slide is if you see the detection radius that is defaulted to 5 meters, my suggestion to you is you change that to 20 meters. 5 meters is actually quite a small radius for a lot of racetracks, and if you don't drive within a 5 meter radius of the latitude and longitude that you insert, the beacon will be ignored. So the bigger the radius, the more likely you are to drive through the radius. A big radius does not affect the accuracy of your lap times. The accuracy of your lap times is still based around the actual latitude and longitude center point that you're using. It just gives you a radius that you have to drive within before it will trigger the beacon. Make sure you don't put it too large so that your detection radius also overlaps another portion of the track if you have another area close to your start-finish line. That will also mean that you'll get a beacon on the back straight, for instance, and the front straight if they're quite close to each other. But generally 20 meters I've found to be a good detection radius. Once you've entered those bits of information, you need to tell the MoTec dash what the coordinates are for the track that you're going to. So you just need to click on the edit button right there. Once you've clicked edit, the GPS coordinates editor window will pop up, and you can click on the add button. You can change the coordinate format, but all of our information that we will provide to you is in decimal degrees. So as a general case, leave decimal degrees as it is, and just choose the add button to put in your coordinates. Once you click add, you'll get a screen that allows you to type in the GPS coordinates as you can see on the new slide. The latitude and the longitude should be supplied to you. Now that file that I've provided to you in the file share window on the left, that actually has got a list of a lot of common GPS coordinates for all different racetracks all around the world. Not everything's going to be there, and you might be racing somewhere on a non-permanent circuit near your area, so we won't have, and nobody will have, the GPS coordinates to give to you for that area. These GPS coordinates are from places that people have already been to that they've given us the information from. So I've just been accumulating them in a file, and hopefully the one you're after will be in there. So in your dash software, you need to type in exactly the full GPS latitude and longitude that's displayed in that file. So when you look at what we've done in where the arrow is there, the number is 131.0353098. You do need all of the resolution to be correctly typed in there. If you type in incorrectly here, you may find that you are in another country, another state, or somewhere else around the globe. So you do need to make sure you type those numbers in correctly. If you get the numbers wrong, lap timing won't work. So this is probably one of the most important parts of the process. Once you've got those bits of information in there, you need to just click OK, and that will save your new GPS coordinates. These coordinates will then be used to generate lap time, running lap time, and lap speed. So you can just click on the lap time tab and select lap time, running lap time, and lap speed, and it will use those with the GPS information that you've just provided. Now, there are some instances where you will go to I2 and you won't actually have your GPS latitude and your GPS longitude available to you. So there are other ways to actually go and get your latitude and longitudes. One of the ways to get your latitude and longitude is you can actually go to Google Earth and find the place where you want your beacon to be. In Google Earth, you can write down the latitudes and longitudes from the cursor position that tell you where your racetrack start and finish line is. This method is very inaccurate, so you would want to put a large detection radius in it, and once you've actually been to the track, I would suggest to you that you trim down the number that you use to be more accurate representation of the actual position of the beacon. If you don't have access to Google Earth to get this information, you may have to do your first session at a new track without having your lap times. So what you do is you put in all the lap time information for GPS that we've already talked about, and you send it to your dash. You don't worry about setting the coordinates because you don't know what they are. So you go and do your first session driving around the track. When you've finished your first session, you can come in and download the log data out of your car. Once you've got the log data downloaded, you can then open up I2 Standard and go and have a look at the GPS information in your log data. Generally in this instance, I would suggest you use the circuit project. So open up I2 Standard and open the circuit project up. When you open the circuit project up, you'll see a screen that looks like this, which is showing you all sorts of information, but you don't have any log files open. So you need to click on the Open Log File part of the File menu, and when you go into there, you should try to select the racetrack and the log data that you've just created. You'll actually see there's no lap times and no laps in a log data, piece of log data that does not have GPS beacons working. So this is a good example in front of you where you'll see the fastest lap time is 61 minutes and 50 seconds because it's an entire session of 60 minutes without any actual lap times being triggered by the GPS beacon. So if you just select that and click OK, you'll be brought out a screen that looks much like this. As you can see, there are no lap times, there are no separators, and it shows at the top in the circle there are no laps in your data. If you forget to set your latitudes and your longitudes, you will also have this same problem where you won't be able to see any laps. So how do I put lap times in here now, and how do I find my GPS latitude and my GPS longitude so that I get lap times the next time I go out and run the car? Well, the first thing you need to do in I2 Standard is untick the lock layout. If you leave that ticked, you won't be able to modify any of the screens. If you're in I2 Pro, you don't need to do this. You should now click on the spare component and then right click on the worksheet and then click delete. This will give you a spare place to go and put a new worksheet with your GPS information on it. On your blank sheet, you can now right click on the blank area, click add, and then click a time distance graph. Once you have this blank graph in front of you, you can right click again, click on time distance graph properties. When you're shown the blank time distance graph properties window, you need to click on the Add Channel button, which is right at the bottom of that screen. When you click Add Channel, you'll be given the Select Channel window, which is the next one we're showing to you. If you type into the search box GPS, you'll be given this list, which is GPS altitude, GPS heading, latitude, longitude, GPS satellites in use, and often you'll also see GPS speed in this list. All you need to do is select GPS latitude and then GPS longitude and put them into the time distance graph properties and click OK. So there you can see how you would do that. You should also add a group so that your latitudes and longitudes aren't overlaid over the top of each other. So you can see the Add Group button in the bottom left corner. When you are finished, you should see the time distance graph properties as displayed on the right. Group 1, latitude, Group 2, longitude. This is what your screen would look like in that instance. You can see lots of squiggly lines going up and down and not a lot of it making much sense. From here, you should actually drag your cursor back and forth, and on the track map in the bottom right corner, you can see whereabouts your car position is compared to your track. Move it back and forth until you have the beacon position in the place on the track where you would like it to be. And then you can click on Tools and then Lap Editor. When you click on Lap Editor, in the new version of i2, so you'll have to grab the latest version of i2, in the new version of i2, you've got an option under the Lap Editor that says By GPS. When you select By GPS, you'll be brought up this screen that says Auto Insert Beacons by GPS, and the latitude and longitude that's shown in this box is the latitude and longitude that you just selected in the previous window. So it automatically grabs from the main window of i2 where your cursor is and puts the latitude and longitude into this auto insert box. It also has a tolerance in meters, which is the beacon circle that we talked about before. Again, I would suggest this gets turned to 20 meters. When you click Execute, it will run through your data and try to find any times your car has passed the latitudes and longitudes you have just selected. And as you can see in the lap editor on the right, it's just added 12 laps or more into this data. When you go back to the screen, you can see there are now 23 laps of data in front of you, and on the display you're only seeing one lap, which happens to be the fastest lap, and that's lap 1. If you pressed F2 at this point, you could zoom out and you could see all of your laps with all of your data split up into individual laps. If you were to click F8 or the data flyout from the left-hand side of i2 Standard, you'll be shown all of your lap times that have now been generated based on this GPS location. If you actually have just an M800, for instance, you don't have the option to set up the GPS beacons within the M800 itself. So this method I've just shown to you, where you would unload your M800 data with the latitude and the longitude, you select where you want your beacon to be, and auto insert means that finally with an M800 you can use GPS to create lap times within your ECU data. This is the screen that you would use with your ECU data to make laps appear in your ECU data. So now with a GPS in a MoTec ECU, you can get lap times and you can get track maps from just ECU data and nothing else. So you're at the track and you're having problems with your GPS. Here's some things that you can actually try. Make sure that you are supplying only 5 volts to the Garmin GPSs. It says this in the manual, it's on the wiring sheet, but make sure you only use 5 volts. Unfortunately, it isn't a 12 volts GPS, and if you put 12 volts into the GPS, it'll be destroyed. This is something you need to make sure before you wire it, and make sure at all times that is the case. You need to check that the transmit pin, the TX pin from the GPS, is wired to the receive pin or RX pin on the dash. You kind of don't need to remember this, you just need to basically make sure that you follow the wiring diagram instructions that are supplied with the GPS. So transmit from the GPS, receive into the dash is what you need to remember. Check the GPS baud rate is correct. Usually the Garmin baud rate is 19.2. If you're having a lot of trouble, you can use a terminal emulating program within your PC to actually place the RS-232 receive data in and try to see what the data looks like. Normal GPS data is easily readable, so you can tell straight away whether it looks like real data or not, because you should be able to read the information in a terminal emulating program. You should always check that the GPS is mounted flat and externally to the car, and if it's on a non-metallic surface, we recommend using a 150mm square or round, for that matter, piece of aluminium or steel as a ground plane underneath the GPS. If you're trying to get satellites to work in your car that you've just set up and you're in your garage, there's every possibility you won't see any satellites while the car is still inside the garage. You'll generally have to push your car or boat outside of the building and leave it with direct line of sight to the sky, just like any other GPS. If this is a brand new GPS, or the GPS has been previously working in a location a long way from where you are, it can take quite a long time for a GPS to actually get satellites and to show you a position lock. This can take many minutes. We show here up to 5 minutes, but I could suggest to you it will take a lot longer than that in some instances. So allow your GPS to sit even up to 30 minutes when you first start to use it to make sure it gets a lock on your current latitude and longitude. This is not unusual or uncommon behaviour. All GPSs will work like this. Once you get to a place where it has a lock on your latitude and longitude, the next time you power the unit up in the same area, its lock time will be far faster, around about the 1 minute time. If you're racing and you need to have GPS lock as soon as you get going, I would recommend that you take your car out of the garage, power the car up with a few minutes to go before you're being called up. That way it'll give your GPS time to get a lock before you start out on the racetrack. If you're not getting lap times, make sure you check your start-stop beacon coordinates again. Go and grab your coordinates out of your dash and have a look and write down what you've got in your dash. Go and then check them against your log data and see whether you are really crossing those coordinates with your log data. If you're not crossing those coordinates, you need to adjust the coordinates you're using, as we've shown you earlier, in your dash. Give them the new coordinates and then send yourself back out to the track. GPS is a really useful and inexpensive way to do lap timing, and it's really good for club to middle level motorsport and certainly boats. Hope this information has been good and has helped you with your usage of MoTec GPS beacon.